Hello student, how are you all? Welcome to Creata Classes. I am Gurmeet Singh and also welcome to our series on chapter circle for class 10 student. In this series we have covered all this lecture and this is the last lecture of the series in which we will cover the revision of the complete series. You can use this lecture to just refresh the concept or one day before the exam whenever you feel it is right. Also download the PDF of the concept and formula list that will be helpful to cover this revision lecture. The link is given in the description. There you will also find the other PDF of the concept and formula list for other chapters too for class 10 student. Check the link in the description. So without taking any further time, let's start with the last lecture, the revision of the complete series on chapter circle. Here it is and best of luck. Firstly, let's start with the circle. Circle is basically composed of many points. These points are infinite in number, so circle is composed of all of these points. Let's also understand the intersection of the circle with a line segment. We will take three cases. In the first case, we are having a line segment which is just passing by the circle. This line segment is not intersecting with the circle. This is called non-intersecting line. No intersection is there. In the second case, we are having a line segment which is intersecting with the circle. This line segment is called secant. By definition, secant is a line segment which intersects the circle at 2 points. If you observe, this line segment is intersecting the circle at these 2 points. So this is a secant. Further, the third case. In this case, the line segment is just touching the circle at 1 point. We have seen that circle is composed of infinite number of points and this line segment is just touching one of the point. This is called tangent. By definition, tangent is a line segment which touches the circle at only one point. Got it? In the secant is touching the circle at 2 points, while in the tangent it is touching only at the 1 point. This is the major difference. And this chapter is all about the tangents, the various property, theorem and the questions based on tangents related to the circle. Let's understand more about the tangent. From a single point, we will have only one tangent. We cannot have more than one tangent from a single point. Suppose we are having a point on the circle, how many lines we can draw from this point? We can draw infinite number of lines and out of all the infinite number we will have only one tangent. All the other line will intersect the circle at 2 points. So all those lines will be secant. 1 point, 1 tangent. This is the concept. And we have infinite number of points on the circle, it means we will have infinite number of tangents on the circle. 1 point, 1 tangent, infinite points means infinite tangents. Further, let's understand some of the properties of the tangent. Basically, we are having two important properties based on which we can have various cases. The cases also we will discuss at the end. The first property comes under the theorem 10.1. I am not going into the proof of the theorem. Just the concept is that whenever we are having a tangent and we are having a radius, both will be perpendicular to each other. Tangent is perpendicular to radius, forming an angle of 90 degrees between them. This is the important concept and will be used in solving many questions. Suppose on this circle we are having one more point and from this point we can have only one tangent, just we have seen, and from this point we can have only one radius. And as per this concept, the angle formed at this point is 90 degree angle. The angle between the tangent and radius is 90 degree. Similarly, we can have a point here. Here also we can have one tangent and one radius, and the angle between the tangent and radius is 90 degree. Similarly, you can have any point and you can apply the same concept. Further, let's move to the next concept that comes under the theorem 10.2. Before going to this concept, let's take the three cases. In the first case, we will take the point is inside the circle. In the second case, we will take the point is on the circumference of the circle. In the last case, we will take the point is outside the circle. And in all the three cases, we will see how many tangents are possible. Let's take the first case. In this first case, we are having the point inside the circle. The answer is that we cannot have any tangent from the point inside the circle. If we try to draw any line segment from this point, all these line segments will intersect the circle at 2 point. And what is tangent? Tangent is a line segment which touches the circle at only 1 point. All of these line segments will be secant. They are crossing the circle at 2 point. So in the first case, we cannot have any tangent. Let's see the second case. In the second case, we are having a point on the circumference of the circle. This is a point, and the concept is that we can have only one tangent from the point on the circumference of the circle. The same thing we have already covered in the starting. The answer is only one tangent. The interesting portion is with the third case. In the third case, we are having a point outside the circle. Let's draw the line segment from this point P toward the circle. So all these line segments are originating from the point P. If you observe, and the important concept is that we can have only two tangents from the point P which is external to the circle. All the other line segments are not the tangent. These line segments are the secant, these two line segments are the tangent, and all the other line segments are the non-intersecting line segment. So we can have only two tangents from the point external to the circle. The point inside the circle will not form any tangent, zero tangent. The point on the circumference of the circle will produce only one tangent. And the point outside will form total two tangent, 0, 1, 2. So these are the two tangents, and the interesting thing is that that is also part of the theorem 10.2. Both of these tangents will be equal to each other. Here PA is the length of this tangent and PB is the length of this tangent. So PA and PB both will be equal to each other. The concept is tangents from an external point to a circle are equal to each other. So this is also the theorem 10.2. Again, I'm not going into the proof of the theorem. Just this is the concept. So we got two concepts. In the first concept, we have seen that tangent and radius are perpendicular to each other. In the second concept, we have seen the tangent from an external point will be equal to each other. And we can have two tangents from the external point and these two tangents will be equal to each other. Based on these two concepts, we can have several cases on which we can frame different type of questions. Let's understand these cases. Let's take the first case. In the first case, only the first concept is applicable. That is, we are having a tangent and tangent is touching the circle at the point P, and A is the external point and O is the center and OP is the radius. The concept is that if we join point A and O, we will form a right angle triangle. How? The first concept, the theorem 10.1 concept, radius and tangent are perpendicular to each other. So this angle will be equal to 90 degree. So this triangle, the triangle AOP, will be a right angle triangle. So we can apply the Pythagoras theorem in this concept. That is, AO square is equal to AP square plus PO square. Based on this concept, you will see the small questions in the examination, and also based on this concept, you will be able to solve the big question. So keep in mind, whenever you are having a tangent and the radius, you will be able to form a right angle triangle and you can apply the Pythagoras theorem. Let's move to next case. In this case, we are having a circle and we are having an external point P. And we know from the external point, we can draw two tangents. These are the two tangents. As per theorem 10.2, these two tangents will be equal to each other. These two will be the radius, so both will be equal to each other. And as per the theorem 10.1, these two angles will be equal to 90 degree. Tangent and radius are perpendicular to each other. So these type of figures you will see in the examination. This angle will be 90 degree and these two tangents are equal to each other. The next concept involves the concept of the congruency. The congruent triangle are basically the two triangles which are copy paste of each other. Let's join O with P. Are you able to observe the two triangles in the given figure? Here both of these triangle will be congruent to each other. Both are a right angle triangle. Both of this angle is 90 degree. Both of these are the radius and both of these tangents are equal to each other. Further, OP is also the common side. So we are having various factors through which we can prove both the triangles are congruent to each other. This is very important. Whenever you are having the two tangents, then the triangle formed by the tangent, radius and this line will be congruent to each other. Once we got the two triangles as congruent, we can say all the three corresponding sides and all the three corresponding angles will be equal to each other. It means both of these angles will be equal, or in other words, we can also say OP is the angle bisector of this angle. OP is dividing the complete angle into two parts. Here this angle is formed by the two tangent, and OP is a line segment which is joining the external point and the center. So in the refined words, we can say the line segment joining the external point and the center will divide the angle formed by the two tangents into the two equal parts, or OP is the angle bisector. This is very important concept and many questions are generally asked on this concept of the congruency. So you should know this. Further, if we join the point A and B, you will form a chord. What is chord? Chord is just a simple line segment which is formed by joining the two points on the circle. So AB is a chord. The interesting concept is that the line segment OP, which is the angle bisector of the angle P, is also the perpendicular bisector of this chord. Here both of these line segments will be equal to each other and both of these angles are 90 degree. You can apply the concept of the congruency to prove the same. Here these two triangles will also be congruent to each other. These two triangles will also be congruent to each other, and these big triangles are already congruent that we have seen. And these two line segments are equal, these two angles are equal and both are equal to 90 degree, and these two angles are also equal. So this is one of the case based on which many questions are asked. Students, a small information: download the formula and the concept list. The link is given in the description. You will also find the similar formula and the concept list for all the chapters for class 10th. Check out the link in the description. So again, back to the lecture. Let's move to the next case. In this case, we are having the circle inside the triangle, the circumscribing case. In this, we are having a circle and a triangle, and triangle is touching the circle at the 3 point. Once you got this type of question, just try to identify the external point. Here A, B and C are the external point, and from this external point we are getting two tangent. For example, from the external point A, these are the two tangents which will be equal to each other. Why these two tangents are equal? The concept 10.2, the theorem 10.2 we have applied. From an external point, the two tangents to the circle are equal. So these two tangents will be equal to each other. Similarly, from the point B, these are the two tangents which will be equal to each other. And from the point C, these are the two tangents which will be equal to each other. So we have applied the theorem 10.2. Let's also apply the theorem 10.1. Here the center and the point of intersection of the circle and the triangle will be the radius. So this is radius, this is radius and this is radius. And as per theorem 10.1, the tangent and the radius are perpendicular to each other. So this angle and this angle will be 90 degree angle. So we have applied the theorem 10.1. Further, if we join these three line segments with the center point, we got various triangles inside the figure. We are having total 6 triangles. And if we take the adjacent two triangles, suppose we have taken these two triangles will be a right angle triangle. We can apply the Pythagoras. Further, these two triangles are also congruent triangles. So this is the concept, and as per the specific question, these data change. So you have to pay attention to the question, what the question framer is asking in the question, and based on that you can come up with your own concept. Overall the concept will remain the same. So let's move to the next case, in which we are having the quadrilateral and the circle. This circle is touching the quadrilateral at the 4 point. On observing, here we got the 4 external point to the circle which are having the respective tangent. Suppose we take the point A, here we are having these two as tangent, so these two tangents will be equal to each other as per theorem 10.2. Similarly, we are having 3 more external points, and from these points we are having the two tangents. Both the tangents will be equal to each other. And also if we form the radius, here the 4 radius will be applicable, which comes under the theorem 10.1, which shows that the radius and tangent are perpendicular to each other. So these angles will be equal to 90 degree. Here also you can form the different type of triangle. 8 triangles will be applicable and you can play with these triangles to form the different cases. So this is the case of circle and the quadrilateral. Let's move to next case. In this case we are having two concentric circle and the chord AB. Here this is the chord AB to the circle C1 and this chord is touching one of the point to the circle C2. For this circle C1, AB is the chord. What is chord? Chord is a line segment which touches the circle at 2 points. And this same chord AB is acting as a tangent for the circle C2. And what is tangent? Tangent is a line segment which touches the circle at only 1 point. So AB is touching the circle C2 at only point P. So AB is tangent for circle C2 and AB is chord for the circle C1. So this is the important concept, you should know it. So we have done with the revision of the complete chapter and the complete series. So students, we have done with this lecture. If you have enjoyed, like and subscribe to our YouTube channel and also share this video with your friends and the class 10 student. We also have a similar kind of video, all the chapters for class 10 student. Check the playlist section of our YouTube channel. And best of luck for the exam you are preparing for and have a great day. Bye for now.